All right, continuing with functions, we're going to take a look at inverses. So this is kind of a continuation of what we're doing with function operations. So here's our function, and it's in set notation, and again, we could find the domain. It's -7, -5, 4, and 7, and we could find the range, and that's 3, 1, 2, 3. And then last time we even talked a little bit about an inverse. So if I wanted to do the inverse of this function, I switch x and y. And in fact, if there's any one thing to remember from this lesson is that's what we do with the inverse. We switch x and y. And it's also very important to remember that essentially functions undo some, or inverses undo something. So here we have our inverse, and we are going to switch our x and y. So basically, my domains and ranges switch around. Now hopefully we're going to see a problem here with this. See, right here, I have -7, -5, 4, and 7. So this is a function. So this relation is a function, but if I take a look at the inverse, look at my domain here. I have it repeat. So remember, functions don't have repeated x's, so this inverse is not a function. But it is still the inverse of the function that we were given. So when we're doing inverses, we will need to take a look at whether or not the result is a function. So here we have g of x, and what we're going to do is, first of all, we're going to, instead of saying g of x, we're going to say y equals 5x minus 7. And if I want to find the inverse of this, I'm going to do exactly what I did over here. I'm going to switch x and y. So x, and wherever there's an x, I'm going to put a y. Now I solve for y. So I'm going to add 7 to both sides. And then I divide by 5. Everything divide 5. So now I'm ready to say what the inverse of this is. G inverse of x is x plus 7 all over 5. All right, this next one, I'll do the same thing. So I have y equals root 2x minus 1. I switch x and y. And now I solve for y. So to undo a root, I'm going to square it. So I get x squared equals 2y minus 1. Then I add the 1. And then I divide by 2. Everything divide 2. So I'm ready to say what the inverse of h is. H inverse of x is x squared plus 1 all over 2. No problems. Now sometimes what we're asked to do, as is the case right here, is to find the inverse by its graph. So here I have a function, and I'm going to need to graph it. So to graph this, I find my vertex. My vertex is 0, 1. So that's where I'm going to start, 0, 1. And then if I go right 1, 1 squared, 1. And then if I go right 2, 2 squared, 4. And use my axis of symmetry. And then if I go right 3, 3 squared, 9. So up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I have my parabola. Okay, now, how do I graph an inverse? Well, remember, what do we do to find inverses? We switch x and y. So that's what I'm going to do. I find some points on here that I can switch x and y with. So let's get our ordered pairs. So this is the point -3 and 10. This here is the point -2, 5. This here is the point -1, I mean, and 2. This is the point 0, 1. This is the point 1, 2. This is the point 2, 5. And this is the point 10, negative, or 3, 10. Okay, so now to graph my inverse, I switch all the x's and y's. So this point becomes 10, negative 3. 3, 4, 5, 6, 7, 8, 9, 10. Down 3. 10, negative 3. There's my inverse. 5, negative 2, so I switch x and y. 1, 2, 3, 4, 5. And then down 2. And then this is negative 1, 2, so 2, negative 1. And then this one will become 1, 0. And then, as I can imagine, all the other points also reflect. So I get a sideways parabola. And I'm not connecting my dots very well. But if we take a close look at this, what we would see is that it's like it's flipped over this line, right? Kind of like geometry class. All these points are flipped over. But what we really want to do is simply graph our function and then switch some x's and y's from that in order to graph it. All right, so let's say I have my two functions and I want to find some inverses of these. Just to practice it, get a few of these. What do I do next? I switch x and y. Now I'm going to solve for y, so I'm going to add the 7. And then I square root to undo my square. So I get root x plus 7 equals y squared. So f inverse of x equals square root x plus 7. Now, like earlier, I was talking about domains and range. What I want to know, like if I take a look at this inverse right here, big messy. If I take a look at this inverse here, notice that this fails what's called a horizontal line test. We have a vertical line test to know if it's a function, but a horizontal line test will tell us if its inverse is a function. So it fails the horizontal line test. And in fact, when I take a look at my inverse right here, if I did the vertical line test, I would see that it fails the vertical line test, thus meaning my inverse here is not a function. So I am concerned with my domain and range. So I might want to understand, well, what is the domain of this thing? So a way to find domain is to ask, well, what don't I want? And in here, I have square root of x plus 7. And I know that if I do square root of 0, well, that's 0. And if I do square root of negative 1, well, that's an imaginary number. That's I. So in general, if we're graphing these, we don't want the imaginaries. So what we're going to say is this x plus 7, I know that that has to be bigger than 0, or at least equal to 0. So I know my domain is x, such that x has to be bigger than 7, negative 7. Let's try this one. So I replace my g of x with a y, just because it's easier to write that. And now I switch x and y, because I'm going to find my inverse. And now we're going to solve for y, but it's very tempting to go ahead and expand this, but I don't want to do that because that's going to make it actually much harder. So I'm going to add the 2. And then how do I undo this square root? So I get root x plus 2. Then equals y plus 3. Now I do remember I get a plus or minus. Whenever I take a root, I should have done that over here. Whenever I take a root, I get a plus or minus as part of solving. So subtract the 3, and I'll get negative 3 plus or minus square root x plus 2. Okay, so I want to know is, so this is my inverse, so inverse of g of x. I'm going to just take the principal root of this for now. But it is important to remember when as solving radicals with radicals that if you take the root as part of solving, you get plus or minus. All right, is this a function? Well, no. because it would be this deal, right? And we'd fail the vertical line test. So I do want to know what my domain is. So I'm going to say domain, and this x plus 2, I know that has to be bigger than 0. So x has to be bigger than -2. So I say the domain is x such that x is greater than or equal to -2. All right, we are almost done. The next question that we might be asked to do is we are given two functions. We're asked, are these functions inverses? So we need to remember that inverse is undue. So down here, I'm going to write the key to this. If I do f of f inverse of x, what would I get? Well, an inverse undoes. So if I put an inverse in the function, I should just get x. And likewise, if I do, and I'm going to write it the different way, if I do f inverse compose f of x, what would I get? X, because the inverse undoes f, so I just am left with x. What if I had an a in here? Well, then I'd get an a. What if I had an 8a in here? Then I'd get 8a. All right, so what I'm going to do is I'm going to compose these two and see if I get an x only. So I'm going to take this one, and it doesn't matter which way I do it, and I'm going to put it into x in here. So I get 2 times a half root x, square it. Now, a half squared is a fourth, and if I square the root x, I get x, and I get a half x. So no, those are not inverses. All right, I'll pick this one. Now, it doesn't matter which order I do it in, but I'll do it this order. I'm going to put all of this into x in the other one. So I have 2 times x plus 9 all over 2 minus 9. Now I see that these 2's would cancel. So I have x plus 9 minus 9, and 9 minus 9 is 0, so I get x. So yes, those are inverses. All right, I'll do this one the other way. I could take this and put it into x down here, just to emphasize it doesn't matter which way I go. So I would get root 3x squared all over 3. Now a square undoes a root, so I get 3x over 3, and the 3's will cancel, leaving me with x. So yes, those are inverses. So if I compose the inverses, I get, if I just get x, then they were indeed inverses. All right, right here, I'll put this one into x right here. So this is just a composition. So all of these are divisible by 2, so I go ahead and do that. So essentially I did this. And I get x plus 6, so no, those are not inverses.